All right, let's get right into it. We're going to explore the world of web security testing, but not like it's some dry, boring manual. Instead, think of it like a strategic cat and mouse game. It's really all about learning to think like an attacker, to find the weaknesses before they do. This analogy from security expert Dennis Verdin just hits the nail on the head. So many apps are only tested for the most obvious head-on attacks. But that's kind of like crash testing a car by only hitting it from the front and then completely ignoring all the other ways things can go wrong. And that's the thing. Just like making a car safe means you have to test it from every possible angle, securing the apps we use every day means we have to think about every single way an attacker might try to break in. Not just the obvious stuff. You've got to think about side impacts, rollovers, even somebody trying to just straight up steal the car. So this is where that attacker's mindset really kicks in. And the first step? It's surprisingly simple. It's all about reconnaissance, finding really sensitive clues that were accidentally left out in the open. It's basically like finding a dropped set of keys lying on the sidewalk. And one of the most powerful tools for this is something with a great name, Google dorking. Now, this is not your everyday Google search. Not at all. It's a way of using Google's own advanced search commands to peek behind the curtain of a website and find things that were absolutely never meant for public eyes. I mean, a simple command like this one can act like a time machine. The cache command shows you what Google remembers about a site. And that can include really sensitive info from older versions of a page that a company was so sure they had deleted for good. And the amount of sensitive data you can find this way is just staggering. We're not talking about little minor details here. This technique can turn up logging pages for a company's internal systems, lists of usernames, totally unprotected folders full of documents, and sometimes, you won't believe this, even files with passwords stored in plain text. Testers will also dig into files like robots.txt. Now, this file is literally a set of instructions telling search engines, hey, please don't look at these specific parts of our website. But for an attacker, that's not a warning. Oh no, it's a treasure map pointing directly to all the places the company really, really wants to keep hidden. So the second mindset really builds on that first one. It's not just about finding what's accidentally been made public. It's about actively hunting for things that were hidden on purpose, like secret backdoors left behind by developers. Okay, picture this. A developer is building an app, and to make their life easier, they create a secret password or some kind of magic code to bypass all the security while they're testing. Makes sense, right? But what happens if they forget to remove it before the app goes live? Well, it becomes a massive gaping hole in the security. And this isn't just a hypothetical. This is a real-world example right here. A security tester discovered that by adding this ridiculously long, random-looking string of characters to a URL, boom, they were instantly logged in as an administrator with total control over the entire application. No username, no password, just access. This quote just captures it perfectly. An automated scanner would never find something like this. It's programmed to look for predictable patterns. It really took a creative human mind, someone thinking like an attacker, to even bother looking for something so weird and out of place. All right, so for the third mindset, we're shifting gears completely. We go from finding things to actively breaking things. The goal here isn't just to use the application as intended. It's to mess with its logic, to throw total chaos at it, and just see what happens when it gets confused. A creative tester isn't just going to click the buttons they're supposed to. Nope, they're going to send it unexpected data, total gibberish. They're going to ask the application to do things that make absolutely no sense, all to see if it cracks under the pressure and maybe reveals something it shouldn't. So, for example, if you send a nonsensical request like get/Santa Claus, different web servers will actually give you slightly different error codes. An Apache server might say bad request, but an Nginx server might say not found. And these tiny little differences, they're huge clues that help an attacker start to figure out how the system is built and where its weak points might be. And this same logic applies to a company's business rules too. If an online store, say, keeps the price of an item in a hidden field on the web page, a tester isn't just going to accept it, they're going to intercept that data and try to change the price from, say, $2,000 to just 1 penny, just to see if the server on the other end is naive enough to accept it. So what all this really shows us is that securing our digital world isn't about just running down a simple checklist. Not at all. It's this continuous, creative hunt for flaws. It takes real ingenuity and a deep, deep understanding of how things can be broken.
Take a look at this number, 329. What is that? Well, that is the number of individual security requirements a company has to meet just to handle credit card data using its own systems. It is a staggering amount of complexity, and every single one of those requirements is a potential place where things could fail.
So, in the end, security testing that actually really works really comes down to adopting these mindsets. You've got to be a digital detective, finding clues in plain sight. You've got to be a hunter, looking for those secret backdoors. And you have to be a bit of a saboteur, breaking the rules to find the holes before the real attackers do. And at the end of the day, just trying to hide your flaws and hoping nobody finds them is a losing game. I mean, sure, it might stop the least skilled attackers, but the only real defense is a constant commitment to hunting for these flaws and actually fixing them.
It really is a never-ending battle, isn't it? A constant war between the people who build and defend our applications and those who are relentlessly trying to break them. This constant hunt, this embrace of the hacker's mindset, is what keeps our digital lives safe. Which leaves us with a pretty big question. Are the defenders winning?